Okay, so this video is about using matrix to solve linear systems. But before we move on to discuss more in depth about matrix, let's review different ways or the methods to solve systems of linear equations that you've learned so far. The first method is graphing. Okay, so we talk about graphing the relationships between two lines. Here we talk about linear equations, right? So that's representing lines, okay? So a couple of representations, so there's several scenarios, a couple of scenarios that you can think about. One scenario is that the two lines are, you know, the two lines intersect at one point. Okay, so for example, if you're looking at this graph over here, you see that let's say that you have two lines, line one, line two here, and they cut at only one point. So we say that the system has one solution. Okay, another situation, possible situation, is that let's say we have two lines, but this time the two lines they don't intersect with each other, meaning that they are parallel with each other. Okay, so in this case we say there's no solutions. And then the other scenarios, third scenario is that you have two lines, but then these two lines are the same. Okay, so the two lines are the same. So we would say that the system has infinitely many solutions. Now, the second method is substitution. So pretty much you express one variable in the other terms, and then you substitute that into the one of the two equation or the other equation, and then you solve for a single variable, and then you plug the value of that variable into the other any equations um, to find the other variable. Okay, so I'm not going to go through all of these techniques here because we already covered that in class um, or in previous videos. The third method is elimination, and the same thing, like you try to, as the name indicates, you try to eliminate, you try to cancel one variable so that you can solve uh, a very simple equation, uh, one variable, and then again you plug that variable in to one of the two equations and then to solve the other variable. Okay, Kramer's rule. There are a couple of videos on the Kramer's rule on this channel, so please feel free to uh, find and watch them. But the main focus of this video is about matrix. Okay, so matrix simply is a way to represent systems of linear equations. That's it. So, for example, in our class, we um, discussed that. Let's say that we have a system of two linear equations. Let's say we have x plus y equal to 2 and 2x minus y equal to 1. Okay, so now your job is you are going to represent this, you're going to rewrite this system into uh, a matrix form. Okay, so into a matrix form. So I would recommend you to pause this video and complete this row format, please. Okay, all right. So when you transfer this into the row and column format, you would have for the first row here, So each column will represent a variable. Okay, so you would have uh, this column here will represent x variable, and this column here will represent y variable, and this one here will represent constant. Okay, so your job is to write in each column and row appropriately the number representing each. So for example, let's say, so in this case you would have one slot, two slot here, right? Okay. All right, so this is easier for you. And then, so for this position here, this position correspond to this position here correspond to this position here. Okay, so here, what's the number in front of x here? 1, right? So you would write 1 over here. Okay, the same thing here for this position. This position correspond to this y number here, right? So again, the number in front of y here is 1, so I'm going to write 1 here. All right, and then here correspond to this constant here, so that would be 2. The same thing here, I'm just going to write quickly. So you have 2, and then remember that in this position you have to carry the sign of this of the coefficient. So what's the number in front of y here? You see the minus, right? Minus 1. So you must write minus 1 here. A lot of people make mistake by writing only 1. That's wrong, right? Remember that you have to carry the sign here, and then here you have 1, right? That's it. So if I have to rewrite this, I just have to write like this: 1, 1, 2, 2 minus 1, and 1. Okay, so that is the matrix form. Okay, so we have the matrix form. All right, so one thing that you need to remember is that the rules, so we call row operation rules. Okay, in order to solve the system by using matrix, you have to use rules. Fortunately, there are only 3 rules that you have to remember at this level, right? um, but let's talk about the goals first, right? So your goal for this, let's say that you have this matrix. All right, and then the next question would be, how are you going to solve the system with this? Like, what's next? And think about this. All right, think about this. Let's say that you have let's say that you have let's see this. Okay, and a number here, and then let's say this. Okay, so remember that from this convention here, and then to rewrite this in the matrix form, that's one way, right? But then you have to be able to write from right to left as well, meaning that if you're given this matrix form, you have to rewrite it at xy form, right? That's pretty simple, and we can do that easily. So let's think about this. Let's take a look at this. Okay, so we have 1 0 3 0 1 minus 2 here. So what does it mean, right? So in this case, again, you know that this column represent x and this column represent y. Okay, and these represent constant. Okay, so what does it mean? It means that, for example, here for the first row, right, first line of equation, you would have what? You would have 1x plus what? 0y equal to 3, right? The same thing here, as second line, you would have what? You would have 0x plus 1y equal to minus 2, right? In other words, you will have what? In other words, you would have x equal to 3, y equal to minus 2, right? This is like the solution pair for for this system. Okay, so coming back to the goal that we're going um, to transform this uh, matrix form, the goal is that you're going to have what? Something similar to this, right? So that means 1 over here represent for x, right? So 1 over here represent for x, and this one is 0, so you have 0 here. Okay, and let's say that you have a number, so let's just say I'm just going to have the a here for any number that you want. So just any number here, maybe like constant 1, maybe a number or something like that, right? Well, I would just write mm, maybe E. So E stands for any number, right? And then here for the second row, you would have 0x, right? So you have 0 here, 1y, so I have 1 here, and then another number, so I would say F. All right. Again, E or F are numbers. Okay. All right. So that's the goal. This is the goal that we all have to achieve or aim for to solve it. Okay. All right. Now let's go back to the row operation rules. There are 3 rules that you must follow, and they are pretty simple. The first rule is the exchanging rows, right? So you can exchange rows. Okay, so for example, let's say that I have row 1 and I want to move the row 1 up. Okay, so let's start with a example. Okay, so in this case, all right, let's start with something like this. So I would have 2 1 1 2, and then here I have 3 minus 1. Okay, so this one right now is currently row 1, so I just write r1, and this one is row 2, so I have row 2. Now what happens if I want to move row 2 up here and then row 1 go down? I can do that, right? So that means you can interchange 2 rows together. Okay, like you switching the order of the rows, and that would be okay too. So in this case, the new row here would be what? 1 2 minus 1. Remember that you have to move the constants as well, right? So this is row 2, now it becomes row 1, and then row 1 here becomes row 2. Okay, so that's the first rule. Rule number 2 is that you can multiply any non-zero number, okay, to a row. Okay, so pretty much let's say that so you can say k times row with k is any non-zero number. Okay, uh, k is non-zero number, so that this means multiply any non-zero to a row, and that's okay too. Number 3, and remember that because k here, any non-zero number, it could be a fraction as well, right? Or a okay, or you can multiply by a quotient. Okay, all right. Number 3 is that you can add or subtract 2 rows. That would be okay too. All right. So remember that when you add or subtract any rows, you will have to write you have to write the results in one one row, and you have to indicate that. Okay, so that's the theory, and we learn these rules in class already. So, but let's start with um, an example and see how it works in real life. Okay, so let's say we going to start with something like this. I have 1, 2, -3, and then here I have 2 minus 1, 2. Okay. All right. Now remember that our goal is that I would have what? I would have 1, 0 here and 0, 1 here. Okay. Remember that? Yeah. Okay. So let's take a look at our problem first. Okay. So since we want to have here as 1 here and 1 here, so we already have this position. Let's say that we have this position is 1, pretty good. All right, I'm happy with this. And let's take a look at this position as well here, right? So this supposed to be 1. Okay, this supposed to be 1. And let's say that right now it's -1, but that's kind of okay too. Okay, and I'm okay with that. Okay, I'm okay with that. From here, you can do a couple of different ways. So nobody solve the matrix in the same way. Okay, so you have multiple approach to this, and it's up to you. Like it's creativity. Like it's you can be very creative with the way that you approach to this. So, um, you know, some people would say, all right, so I want this to be 1. And so right now here is -1. So let's multiply everything. Let's multiply row 1, row 2 by -1 so that to get rid of the minus sign. That's okay too. That's okay. And completely fine. But let's take a look at this position. Now this position here is number 2, and I really want it to become 0, right? Okay. And think about this. How are you going to make this to 0? Okay. So go back here. We use interchange rules in rows? Should I switch row 1 and row 2 together to achieve to get this green number here to become a 0? Probably not, right? So rule 1 does not apply here. If I change the two rules, switch two rows, they are not. It's not very helpful. Okay, so let's talk about what about the two other rules. Two other rules are multiply any non-zero number to a row and adding or subtracting two rows. All right, let's see how it works. So let's say that, like, all right, so if I have number 2, right? What do I need to add in order to get to get 0? -2, right? It's opposite number, right? Okay. All right. So this is pretty straightforward. So what does it mean? It means that right now here I already have no -1. All right. So I wish that if this could be a -2, oh, I can add these two rows up, and then it could it could achieve 0 over here. Okay, so that's exactly what I want to do. So usually what happens is that we're going to write our strategy out loud so that to avoid making mistake, because if you don't write out um, what you are planning to do, you know I would say 90 something percent of the time you will make mistake. Trust me, I mean, like, I've seen a lot of students, even you know people, graduate students and undergrad students, made mistake all the time just because they did not write out the strategy, their plan. And also, it's impossible, like, it's really difficult to go back and find out what you get wrong. Okay, so my strategy is, please, my advice for you is always write out what you want, what you do first. Okay, so my strategy here is I'm going to multiply 2 uh, by row 2. Okay, I'm going to multiply 2 by row 2, and then I'm going to add it up to row 1. But later on, if you familiar with this, then you can combine steps. But in this case, I'm just going to be step by step, small step by most small step, right? So again, remember that you're going to multiply 2 with row 2, and then you're going to write the result into row 2, right? Because you want to transform -1 into 2. And remember, this is row 1 and this is row 2, right? So you're going to write the result in row 2. Remember that another tip is that if you don't do anything with any row, then you just rewrite that row. For example, row 1, we don't do anything with it, right? So quickly, immediately, whatever, you're going to rewrite row 1. Okay, so that less of the trouble. Okay, all right, now the new row 2. So row 2 here, you're going to multiply both sides by the number, right? So you're going to multiply 2 to row 2. So 2 times 2 here is 4. So I write 4 here. And then 2 times minus 1 is minus 2, right? And then 2 times 2, remember here, is 4. There you go. And then what happened is that, all right, here we go. We have this. So add these if I add these two um, rows up, then 2 plus minus 2 will be equal to 0. And I want this 2 position here to be a 0, right? So here what I do is I add row 1 and row 2, but then it's important where you're going to write the result. Your result, you want this result to be 0, right? So that this belongs to row 1. So you're going to write the result into row 1. Okay, so in this case, again, row the result will be in row 1, right? So that means row 2 you don't do anything. So again, strategy, my tip is just rewrite row 2. All right, and then now here what we're going to have, let's say row 1 plus row 2, 1 plus 4 is 5, and 5 you write in row 1, so I write 5 over here. Now row 1 is 2 plus row 2, so that means 2 plus minus 2 is 0, and I write the result in row 1, so I write 0 here. And then here minus 3 plus 4 is 1, so I write 1 over here. All right, that's cool. So I have say the 0 here, which is good. All right, 0 here, which is good. Now, so and then now what happened is that you see, wow, okay, so I'm missing now. At first this position is was one, so one here, and this position was one here. But then now, like, they change the number, and you're kind of like upset about it, right? So it is okay to get upset about it, but so it's much simpler than you think. Okay, so don't be upset about it, because think about this. If you want this to be right now is 5, right? Now if you want this to be 1, what would you do? You divide both sides. You divide entire row 1 by 5, right? And that would be resolve. Okay, so here I would have row 1, I divide row 1 by 5, and then I write the answer to row 1. Okay, so again, row 2, you don't do anything, just rewrite it. And then here, row 1 divided by 5, 5 divided by 5 is 1, 0 divided by 5 is 0, 1 divided by 5 is 1 over 5. Voila, simple, simple, simple. Okay, all right. So now you want what's next? You want uh this position here. You want this to be 0, right? Okay. So again, what you're going to do is you're going to multiply row 1 by 4, right? So if you multiply row 1 by 4 here, that would be 4, and then you subtract row 2. So you subtract row 2. Okay, so that would be 4 times 1 equal to 4, minus 4 here would be equal to 0. So that would achieve our goal. Okay, so again, this position here, I want to turn this into 0, right? So I would write the result into row 2. And do you see that in this step here, I combine, right? So instead of writing 4 times row 1, and then I have another bracket, and then I subtract that into row 2, I combine the steps in this case. Okay. So again, row 1, you don't do anything with row 1, just rewrite it. This helps a lot. So 1 over 5. And then here, all right, so here, so 4 times row 1 here is 1, so 4 times 1 equal to 4, and 4 minus row 2 here, so 4 minus 4 equal to 0, so I would write 0 here. Okay, now 4 times row 1, so 4 times 0 is 0, 4 times 0 is 0, 0 minus 2, so that would be 0 plus 2, so that would be 2 over here. And then 4 times r 1, so 4 times 1 over 5, right? Minus row 2, row 2 is 4, so minus 4. So in this case we have 4 over 5 minus 4, all right? So I would have 5 over here, right? And then uh, 20, so that would be minus 16 over 5. All right, so here I would have 16 over 5. Okay, almost done, almost done, almost done. Now, so pretty much we have what we want, right? We have this 1, we have this 0, we have this 0, that's cool. And then I just have to change this into, I have to change it into 1, right? All right, so how are we doing that? Simple. You're going to divide divide row 2 by 2 and write the answer into row 2 again. So row 1 you don't do anything, so just rewrite the numbers. 0 divided by 2 is 0. 2 divided by 2 is 1, and minus 16 over 5 divided by 2, right? So that would be equal to what? That would be equals to minus 16 over 5 multiplied by 1 over 2. Multiple reciprocal, right? Multiply reciprocal, right? So that would be minus 16. Well, so minus 16 divided by 2, 8 divided by 5 in this case. So what's your conclusion? The conclusion is x equal to 1 over 5, y equal to minus 8 over 5. Okay? Now, one thing about matrix is that you may make a mistake with this, right? So you always have to check for it. Now again, from the original matrix here, you can write it as what? X plus 2y equal to minus 3, 2x minus y equal to 2. So the way that you're going to check it is that you're going to plug x and y into both equations and make sure that they are correct. So again, here I have x here is 1 over 5 plus 2 times y. Y is minus 8 over 5. Okay, and I just want to check. I want to check whether this equal to negative 3 or not. And again, here, down here, I have 2 times x, which is 2 times 1 over 5, minus y. So minus y, remember that minus here, and then y is also minus 8 over 5. And I want to check whether this is equal to 2. So again, here I have what? 1 over 5 minus 16 over 5. So that would be what? That would be um, minus 15 over 5, which is minus 3, which is good. Correct. Okay. And then here I have, down here I have 2 over 5 minus, that would be positive, right? Plus 8 over 5. So that would be what? 10 over 5, and that would be 2, and also correct. So check. So that means the solution for this system is x equal to 1 over 5 and y equal to minus 8 over 5.